So this is the question number 49. It came in GATE 2014 and in set 2. A wastewater stream having flow of 2 meter cube per second, ultimate BOD is 90 milligram per liter, is joining a small river having flow 12 meter cube per second and ultimate BOD is 5 milligram per liter. Both water streams get mixed up instantaneously. Cross-sectional area of the river is 50 meters square. Assuming the deoxidation rate constant is 0.25 per day, the BOD of the river water 10 km downstream of the mixing point is. So basically in this question, wastewater stream. This is a wastewater stream. It is joining a river, small river. So this is a small river which is flowing. Okay. So this is the wastewater. This is the wastewater stream, and this is the small river. Okay, so the flow rate of the stream they have mentioned as QW is 2 meter cube per second and ultimate BOD is 90. Okay, whereas in case of small river flow rate is 12 meter cube per second and ultimate BOD is 5 milligram per liter. So now the question is asking the BOD of the river water 10 km downstream. This is the mixing point. This is the where both the streams are mixing, and they are asking what is the BOD of the river 10 km downstream of the river. This is the 10 km. From here, what will be the BOD? This is BOD at time t. This will be the BOD at time t. That is the 10 km of the downstream. So obviously, to calculate the BOD at this point, we should know the BOD at here at the mixing point. How we will the basic way to calculate the BOD of the mixing point is we will do. So here we will calculate the BOD mix. So formula for BOD mix is BOD mix is equals to discharge flow rate of a stream into BOD of stream plus flow rate of waste water, and this is of river, and BOD of river, Q of wastewater, and BOD of wastewater divided by total flow, river flow and the wastewater flow. So the QR is 12 as mentioned in the question, and the BOD of river is 5. Okay, now BOD flow rate of wastewater is 2 meter cube per second and the BOD of wastewater is 90. So here it is 2 into 90. Okay, now QR plus QW, so 12 plus 2, this will come out to be 17.14 milligram per liter. This is the BOD mix. Okay, now after knowing the BOD mix, so we have to calculate 10 km downstream. Okay, so the water which is there, how many days after which it will reach at this point after 10 km downstream? We know that velocity is equals to discharge upon area Q. Here Q mix, it will be of Q mix. Total discharge is 12 plus 2. Cross section area of the river water is given as river is 50 meter square divided by 50. It will come out to be 0.28 meter cube. Now we know the velocity of the flow. Knowing the velocity of the flow, we can calculate the time taken to travel 10 km distance. Time taken to travel a distance of 10 km is equals to distance by velocity. That is the basic thing. Distance is equals to speed into time. This is the distance is speed into time. We have to calculate the time. So distance by velocity. Okay, so distance is 10 km. Okay, 10 kilometer, and velocity is 0.2 meter per second. Sorry, this is meter per second. This will be meter per second. Okay, because q max will be meter cube. This will be unit will be in meter cube per second. This will be in meter cube per second, and the area is in meter square. So at the end it is come out to be meter per second. Okay, so 0.28 meter per second. But distance is given in kilometer. We have to convert it into meter. 1 kilometer is 1000 meter. Okay, so basically time will come out to be 35714.28 seconds. Seconds, why? Because this based on the unit meter per second, so time will come out to be seconds. If we convert into day, it will come out in the is 0.41 days. Okay, now we have to calculate the BOD at, so we know LT is equals to L naught e raised to minus KT. Okay, now L naught is BOD mix, ultimate BOD 17.14 into e raised to power k value they have given in the 0.25, and day, so 0.41 we will multiply. So water will take this, the stream which is mixing here, it will take around 0.41 days to reach here. So to know, now we know the every in this, if we solve this we will get the value of 15.46 milligram per liter. That is BOD at time t, means BOD at a distance 10 kilometer from the at downstream. So BOD t is 15.46 milligram. So 10 kilometer downstream, this is the BOD of river water at 10 kilometer downstream of mixing point. Okay, so 15.46 milligram per liter is the answer. So in this question, basically we first calculated the BOD mix at this point. Knowing the BOD mix, we then calculated the BOD at time t. Time t means the here t is the distance from here, the water, the time that the water took to reach 10 kilometer downstream from the mixing point. So okay, so using the normal equation, velocity, we calculate the velocity, then using the velocity we calculate the time taken to travel a distance of 10 kilometers. So then we calculate the BOD at time t. Okay, thank you.